Hi again. Okay, so we've worked through this particular absolute value function graphically. We know what it looks like, and we already know it has only one x-intercept and one y-intercept. We circled them on our graph in parts 1 and 2 of this video series. So here is my best attempt at an algebraic solution. It isn't my favorite way of thinking. I am a visual thinker, and many of my students are. But many of my students love algebra as well, and so the wonderful thing about algebraic solutions is that they are plentifully available on the internet and in your textbooks. So I am pretty confident that if algebraic solutions are your thing, you've got resources. But here is mine. Here is my way of making a hybrid of the two, I suppose. Using what I know about the graphical solution, I let that guide me in my sense making of the algebraic. Okay, so there are three cases for any absolute value function, and that is that the inside of the absolute value sign is equal to 0. So I'll just highlight some of that with my pointing tool. Is equal to 0, or it's greater than 0, or it's less than 0. We could also say this equal to 0 positive. This piece is positive, or this piece is negative. So before I started the video, I isolated x in all these cases, and I know from this, and you could pause it at any point here to look at that more closely, that x is negative 2, x is greater than negative 2, or x is less than negative 2. Those are my three cases based on what I know about the absolute value function. So this is me setting up the if this is the case. If this is the case, or if this is the case. The condition on which I'm building the rest of my investigation. Okay, so then if x is negative 2, that's or if y is 0 rather, or if this thing comes to 0, this is only a one possibility here. I can only think about the possibility that if we have the inside of that absolute value function equal to 0, x is equal to negative 2, negative 2, 0 is the only x-intercept, because we have only one way for y to be 0, and that's if the inside of that absolute value function is 0. So we know from at this point we can stop worrying about that x-intercept. Okay, we have it. So I left my thinking, my preset off right here because I thought this was kind of the interesting piece. So what happens when x is equal to 0? Okay, well, we've got two cases left. And I think to be economical about our thinking, we ought to think about the conditions of each of those cases. This piece right here is telling us that x is greater than negative 2. This one is saying x is less than negative 2. Well, guess what? X cannot be 0 here. So x cannot be 0. So there is no y-intercept in this case. Okay, so we can leave that case right off, but we can continue on that middle case to see where our y-intercept will be rather. Okay, so we go back to the function and we say that we're going to sub in the x equals 0. So what happens when x is 0? When x is 0, y is 6. So we have that singular point. So 0 and 6 is our only y-intercept. And that should always be the case. If things are functions, would you ever find two points with the same x value? No, you would not. That would mean we weren't in function land. Remember the vertical line test that you learned from Math 10C? Otherwise, you would have heard that rule known as for any given input, there is only one output. There's uniqueness in that way for any function. So those are our two intercepts, our x and our y-intercept, for the function that Sarah asked about today. Okay, I'm going to call it a day on that problem and then work on this other one that she's asked.